Hello designers and engineers, welcome to a new episode. Today I will be explaining the design process for a door uplick which is usually mounted on the door panel of the car. So I will be explaining the process in this episode. So I will be opening it in CATIA V5. I designed this part on the CATIA V5 software. Actually you can use any software such as NXCAD, CATIA or even SolidWorks for learning. So here is the model. In this video I will be specifically briefly explaining 4 steps involved in designing any plastic injection molded part. This part is designed for manufacturing using injection molding tools. So I will be explaining the 4 steps involved in designing this kind of parts intended for injection molding. So you can use this principle not only for designing the automotive parts but also any injection molded plastic parts. So let's start. Here you can see the various engineering features such as heat stakes, two-way locator and two four-way locators here. These locators are usually used to arrest the degrees of freedom of this movement of this part. There are 12 degrees of freedom along x-axis, y-axis and z-axis. There are 6 translational movements and 6 rotational movements. So using these kind of locators we can arrest all of them, and these heat stakes are used to fix the part permanently onto the door panel. So here is the representation of the door panel. I will unhide it. So it is usually it will look like this after mounting, and using a heat staking gun we will be melting the plastic and permanently fixing this trim onto the door panel. So let's enter into that 4 steps involved in the design process. The first step is conceptual design by the styling team. They will be doing several sketches and things like that to aesthetically design this part. So after that there will be a class A modeler in their team. So he will be doing the class A surface modeling, and the second step after creating the class A surface is they will hand over this class A surface to the NPD CAD team, and initial inspection of class A by surface is done by the NPD CAD team. NPD stand for new product development team. There will be mostly engineers, and what they will do is they will check for the manufacturability and safety of these kind of components. They will be doing some analysis like draft analysis to check whether it is possible to manufacture through injection molding. For example, for this part you can see a tooling axis here, and the draft analysis is done with respect to this tooling axis, and draft angle for this part was 3 degree actually. And if the draft analysis is passed, the whole surface will be shown in green color. So it means it is passed in draft analysis. And if it is exterior parts like the fenders, hoods or bumpers, etc., they will be doing the safety checks to ensure the pedestrian safety and passenger safety. And if there is if they notice any issues regarding the class A surface, they will be sending this class A surface back to the styling team with a detailed report mentioning the issues. So they will be the styling team will try to optimize the design according to that report with the help of NPD CAD team. And if after the optimization of the design, the third step is designing class B surface and class C surface along with the engineering features. The engineering features such as ribs, screw bosses, heat stakes, dog houses, etc. So you can see the engineering features means these kind of things usually used to attach or mount the part to another components. These engineering features should follow the injection molding principle. For instance, in this case, the draft angle for these screw bosses and locators are about 0.5 degree, so it can be easily ejected from the molding tool. So after creating the engineering features and finalizing this design from the side of NPD team, they will be sending this model to the CAE team. So the what CAE, that is the fourth step actually. What the CAE team do is they will be doing several analyses on this design model using several softwares such as ANSYS. So they will be inspecting the strength analysis and other kind of things using this kind of softwares. And if there is any strength issues, they will create a detailed report and send it back to the NPD team. So they can create rips or things like that to locally improve the strength and stiffness of the part. So these are the 4 steps involved in the design process of any injection molded part, especially for automotive projects. They will cover all these steps to ensure the quality and safety of these kind of parts. So here is the simplified view of an injection molding machine. You can see several parts like hopper, reciprocating screw, heating coils, and the mold. These are the important parts of an injection molding machine. Granular plastics will be fed through this hopper, and in automotive industry mostly ABS is used as the plastic material, which is acrylonitrile butadiene styrene. And after feeding the plastic through this hopper, this reciprocating screw will take that plastic granules into this mold cavity through this heating coils, and these heating coils will melt the plastic granules into molten plastic, and this molten plastic will be entering into the mold cavity of the mold. After solidification of this part, it will be this movable platen will be moved and the part will be ejected out of the mold. This is actually a simplified view of injection molding machine. In real life, it is a little bit sophisticated machine, especially this designing this mold and everything. So I will show you the form of plastic granules. It will be in this form. Plastic granules are in this form before feeding into the hopper. In OEMs of automotive industries, as I said before, mostly ABS will be used as plastic material. So this is a Wikipedia page. I will add the link to this page so you can read and improve your knowledge regarding injection molding. So this was today's video, and for concluding, the first step is conceptual design by the styling team and class A surface modeling, and the second step is initial inspection by the NPD CAD team to check whether it is manufacturable or it is following the safety measures criteria. And the third step is designing the class B and class C surface along with the engineering features. Fourth step is inspection by the CAE team to check the strength and everything. So in future episodes, I will be covering all these engineering features in a single video, such as heat stakes, rips, locators, screw bosses, etc. in a single video. I will be explaining the design criteria for those engineering features. So stay tuned. I will be creating a playlist for injection molded parts. I will be also doing a demonstration video showing how to design a injection molded part. I'll be simply showing a video. So stay tuned.